Okay, so I'm going to take a look at workers, but before we do, I'm just going to have a quick look at tentacles. So tentacles are the part of octopus that comes in two flavours. So we've got the deployment targets, which is where your deployment will end up, where you're deploying to. And then we've also got workers, which is a type of tentacle, which is a machine that can execute some of those steps within your process on behalf of the octopus server. So the reasons, I'm just going to step through. So when you set up a tentacle, you choose whether it's going to be a polling tentacle or a listening tentacle. So let's take a look at the listening tentacles. So a listening tentacle will sit and await instruction, await a connection from the octopus server, giving it a task that it's going to carry out. It sits there and it listens on a TCP port. And in this instance, the tentacle is the TCP server and Octopus is the TCP client. All of this, it's secured using SSL on both sides of the conversation. The Octopus server knows the public key of the agent on the tentacle agent, and the tentacle knows the public key via a thumbprint of, both sides know the thumbprint of each other's private key. So this means that we've got a fully secured conversation going on, and it ensures that your Octopus server will only issue commands to the tentacles that it trusts, and the tentacles will only ever accept commands from an Octopus server that they trust. So we tend to favour listening tentacles over polling tentacles for a couple of reasons. First of all, they use less resource, which I'll come on to when we look at polling tentacles. And also, you've got a little bit more control over things like the firewall. So you can lock down your Octopus server firewall because it's polling out to the tentacle itself, and there's only that one port that needs opening. On the other side, you've got polling tentacles. So a polling tentacle will sit and poll in on a regular basis into the Octopus server, looking for any tasks that need to be carried out. So conversely to listening, in this instance, the Octopus server is the TCP server and the tentacle is the client. Again, this is secured in exactly the same way as a listening tentacle through SSL, both having the public keys of the other side of the conversation. And so the actual security, and the SSL is exactly the same. It's just the direction of the conversation that's going on. Now, the reasons you might want a polling tentacle is, say you're deploying to a third party and they're not overly keen on you putting connections through their firewall. So if you use a polling tentacle, it would only need to be an outbound firewall rule that would need to be configured so that the tentacle can pull out to the Octopus server. Also, it might be that you've got maybe in retail or something, some scenario like that, where your tentacles sit on machines that have got dynamic IP addresses or they're sat behind a NAT. So we've talked about resources in the previous slide. So the reason this is going to be using more resources is because the tentacle agent is going to have to sit there and it will have to pull out regularly. Even if there's no instructions to perform, it's still regularly going to have to pull into the Octopus server. And another thing to configure is if you do set up high availability, that configuration is slightly more tricky if you're using polling tentacles. Okay, so moving on to workers. As I mentioned, workers are machines that can execute tasks that don't need to be run on the Octopus server. The reason you might want this is, one reason is that there might be a resource-intensive task that you just want to offload so that the Octopus server isn't put under load. From a security point of view, it might be, there's always that risk, that very small risk that a hostile script or something like that could make its way into your pipeline. And the Octopus server, it runs under a privileged account. And so if that hostile script runs on that, it has a lot of access. So if you can set your workers up to run under different security contexts with not quite such high access, that reduces the risk. And as with any server you're using, you do want to set up the same hardening measures as you would on any of your servers, making sure that the firewalls are closed down, you're all updated, and it runs purely what needs to be run. Something that's recently come out with Octopus in the last couple of months is the ability to scope worker pools. Now, this I think is a really fantastic feature. One use case for this might be, say you've got a deployment process. It's doing some deployments to database servers, and it's also deploying to some sort of web infrastructure as well. So you might say, okay, you've got some workers. So when you set up a worker within Octopus, you assign it to a worker pool. So you would have a number of workers in that pool that the Octopus server can draw upon to perform those tasks. So you might think, okay, when I'm performing these database deployment tasks, I only want to use workers in this specific worker pool. And then you can lock down that worker pool so that it's very, very, specifically just for database access. And then you can use a entirely separate worker pool to deploy to your web infrastructure. Excuse me. Another scenario is the diagram we've got on the screen here, which is maybe you want to use an entirely separate worker pool for your production deployments. And this puts a hard wall between any of your test and dev environments and production. Just adds that, another layer of security into it. And so you can use entirely separate accounts that those workers are running under and give those access to your production resources, but the other workers have none. Okay, so let's take a look at the scoped worker pool. So you can see down at the bottom here, we've got a project.worker.pool variable, and this has a number of worker pools that have been scoped by environment. So we've got 4 environments there: development, production, staging, and test. And if we go up and we take a look at that deployment process, we've got a script task in here, and that script task uses that variable, the project.worker.pool. And so when that script task runs, dependent upon the environment it's used, it will use that variable.